Hello, everyone. Good morning. 안녕하세요. So, I guess since I have 15 minutes, I will kind of get right into things. So, who here is familiar with blockchains? Who here is not familiar with blockchains? Okay. Who here has heard of Bitcoin? Ethereum name service? Any of the blockchain applications looking to use blockchain, store data on blockchains to verify that things like certificates haven't been revoked yet? Okay, fewer, but these things are happening, right? There's universities in places like Switzerland, like Singapore, other places that are kind of increasingly looking at basically kind of putting data on the blockchain and to verify that some certificate has been issued and that there is not a record saying that some certificate has been revoked. Blockchains for remittances and for kind of giving out money to people like refugees. So lots of good and happy stuff happening recently. But for this presentation, I want to kind of zero in on one particular category of happy stuff that has been happening quite a lot in the last year, and I think we're going to see more of, and I would really love to see more of. So it's not just DAOs, but let's start by talking about DAOs. So DAOs, Decentralized Autonomous Organization. It's this kind of term that we came up with back around 2013. It's this thing that a lot of people have been excited about since then. So what is a DAO? Basically, it's a smart contract. So basically meaning a computer program running on a blockchain that directly controls digital assets. And but this is just the definition of a smart contract in general, right? A DAO is a smart contract that holds assets that's meant to last and continue running for a long time, which represents the rules by which some group collectively manages their assets. So this DAOs could be used for many things, right? It could be used to run decentralized grant-giving organizations. They can be used to run decentralized investment funds. They can be used to govern the parameters of some decentralized organization. They can be used for lots of things. Now, who here has heard of the very first DAO, the DAO? So, as we know, this experiment turned out to be a lot bigger than we expected, and then it turned out to fail a lot more quickly than we expected. And back in 2016, and the technology behind blockchains, the technology behind smart contracts, writing code was still kind of very immature. And people hadn't yet kind of thought hard about game theoretic issues, about re-entrancy attacks, about how to write secure smart contracts safely. And this proved to be a big learning experience that led to a huge amount of improvement in things like the Solidity language, and the Viper language, many kind of tools, best practices around how people use and write smart contracts. And very understandably, for a couple of years, there was a period where people were generally kind of afraid to stick lots of money into smart contracts for a very good reason, right? If there's a bug, then your money might disappear tomorrow. Now, over the last year, we've been starting to see this kind of DAO and smart contract renaissance, right? We have over $200 million inside of MakerDAO. We have things like Aragon that are developing more and rising to prominence more. We see the Moloch DAO, which is a DAO within the Ethereum ecosystem that is basically kind of coordinating donations to public good projects that benefit the ecosystem. And we're seeing lots and lots of these things kind of starting to be developed, starting to see more attention and more adoption, right? So a lot of people are using in DAOs, but it's not just DAOs. So let's talk about rules, right? So any kind of formalized institution that we have today. So we have a lot of institutions that are informal as well, but we have many institutions that are formal. So money, corporations, political systems, even like social media, like Reddit and Twitter, I call it a formal institution. You write things, you get points, you get upvoted, you get downvoted, you get karma, yay. And we have like some kind, basically, formalized institutions can be described as some set of rules that define how individual actions affect some common shared state. So if we look at money as a formalized institution, for example, it is basically a database, right? Money is a database that has one rule for how you update it. And the rule basically says, if the number beside my name is like some value, like X, then I have the ability to, at any point, reduce my value to some number Y that's between 0 and X. So I can shrink my balance. And at the same time, I can increase some other person's balance by basically the same amount by which I've decreased my own. Right? So you have a kind of zero-sum rule. Whatever amount I lose is the amount someone else gains. Whatever amount I gain is the amount someone else loses. And you also have this but can't go below zero rule. So money basically just is this kind of system that has a state and that has rules for how individuals can update it. Corporate governance. 4 of 7 people can vote to make a decision. When you have a meeting, 2/3 quorum must be present. Decisions must be published for 1 week, blah, 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 blah. You know, there's lots of kind of rules that you can have in how corporations govern themselves. And this is also an institution, and it defines a kind of mechanism by which the actions of individuals can kind of come together and create actions that represent actions taken by the corporation. And it is an institution in the same way. Social media voting. If I have an account, I can increase the score of someone else's post by 1, and if it's Reddit, I can also decrease the score of someone else's post by 1. I can make my own posts, and their scores start at 1. So all of these things are different kinds of systems of formal rules that kind of help people cooperate. And much of our ability to organize in large groups is based on mechanisms of this type, right? So if you have a smaller group, so maybe less than about 150 people, the kind of commonly cited Dunbar's number, then you can generally kind of do what you want with informal mechanisms. But once you go above that, and once a large portion of interactions are between people who don't directly know each other, then formal systems can really help to kind of guide and align people's behavior toward shared objectives. Now, what blockchains do is they create room for kind of rapid experimentation, building, deployment, and innovation for mechanisms of this type, right? Like formal kind of systems of rules in general. And these mechanisms can be used for lots of things. They can be used to reward contributions to public goods. They can be used to decide how to allocate some limited resource. They can encourage economic activity between participants, govern systems and resources other than coins, like domain name systems, for example. So systems of rules can be used for many kinds of purposes, and blockchains are a pretty good way to build these kinds of things. So let's look at ENS. ENS is the decentralized domain name system on top of Ethereum. Now, if we look at ENS more closely, what you see is that what ENS is it's this fairly complex system of smart contracts that live on the Ethereum blockchain that manage things like registering domains. So if some domain has not been registered, then I have the right to register it. Transferring domains. If some domain is assigned to me, I have the right to change the assignment to someone else. And expiring domains. If the fee has not been paid, then the domain expires, then someone else can register it again. And ENS also includes a very simple kind of proto-DAO, basically just a multi-sig, kind of 4 out of 7 people for managing upgrades. Right, so ENS itself, this system for managing the .eth domains on the inside of Ethereum, is itself a decentralized blockchain-based institution that's very non-trivial in its complexity, and it is being used in practice today. Moloch DAO. So this is this DAO for funding public good projects in the Ethereum ecosystem. And Moloch DAO, of course, being named after the rationalist god of coordination failure, who was in turn named after the Canaanite god of child sacrifice. And Moloch DAO is basically kind of about overcoming Moloch, right? It's about kind of stopping us from kind of self-destructively doing things that are bad for each other and encouraging us to do things that are good for each other. And in this case, this means kind of collectively funding public projects that benefit the Ethereum ecosystem altogether. Moloch DAO has this unique mechanism called Rage Quit. And the idea here is basically, like, what if the Moloch DAO gets kind of taken over, 51% attacked by some set of kind of malicious actors? Then if you participated in Moloch DAO, then you at any time have the ability to basically take your share of Moloch DAO's resources and kind of pluck them out, and just take your share and go away and do something else with it. And so this way, if you have a 51% attack and you try to attack Moloch DAO, then you're not going to actually be able to kind of grab control of other people's money. So this is one kind of innovative and really nice mitigation against what's really a kind of big and fundamental problem in corporate governance. Harberger taxes. So this is this interesting idea that's been kind of proposed over and over again in the last century, and it's this form of kind of partial property ownership. So the idea here is it's this property tax system where for any asset that's covered by Harberger taxes, the current owner of the asset must publish some price at which they're willing to sell that asset, and whatever price they publish, anyone has the ability to buy the asset at that price. Now, why not just set the price to infinity? Well, basically because whatever the price is that you set, that's the price on which you have to pay a property tax. So whatever amount you set, that's the amount by which you have to pay, say, 1 to 5% of that amount every year. So this does a few things really nicely. I mean, one is it can raise ongoing revenue that could be used to fund these other public good projects. I mean, another thing is it also does this without requiring a centralized mechanism to figure out how valuable everything is. And the third thing is it also kind of mitigates some monopoly problems and increases market efficiency, because like if you have something that it turns out to be kind of much more valuable than expected, then kind of it encourages you to set prices that are kind of lower, and so increase the chance that objects kind of become used by whoever actually can use them to create the most value. Now, what we have on the right is this experiment by someone in the Ethereum community, Simon de la Riviere, and what he did is he created this kind of online digital artwork, and he basically created a smart contract to implement Harberger taxes. So right now, whoever owns the thing set a price of 240 ETH, and he basically has to pay 12 ETH per year to kind of keep ownership. And at the same time, if you want to buy the thing, then you can go ahead and pay 240 ETH right now, and then you're free to set your own price for it. Badges. So another kind of more social incentivization. So the idea here is it's an on-chain, non-transferable token and of certifying that you did something. Could certify that you attended a conference, could certify that you donated to charity, could certify that you contributed to open source software. This over here is a picture of a PPath. That's this kind of decentralized Twitter clone. And one of the nice features that they have is this kind of badge system where if you donate $25 to the Against Malaria Foundation, then you get a nice little mosquito picture beside your profile. Yay! So, community savings insurance. So basically here you have applications. Like, this is a common idea that exists in many developing countries where kind of groups of people come together and sort of pool their money together so they can more effectively save. It can also serve as an insurance system. So if you suddenly have a big kind of unexpected expense, some medical expense, something else, then like there's a pool of money that you can take out from. This can be used for savings, credit, mutual insurance, sort of a lot of different things. And there's projects that are trying to implement this as a smart contract system on top of Ethereum. So blockchains kind of make it much easier to build all of these things, right? Blockchains make it very easy to create these smart contracts, these computer programs that just implement the logic for all of these mechanisms. Now, why blockchains? So first of all, blockchains have first-class support for user account security. They have first-class support for cryptography. And so these programs actually can be directly controlled by the actions of users in a very secure way. First-class support for digital assets, first-class support for this idea of kind of global shared state, kind of things that we save, that we all agree on in general. Blockchains avoid centralized dependencies, very important if you want to create applications that kind of span wide social distances where there isn't necessarily a single centralized provider that everyone trusts. And they're a permissionless global platform that anyone can participate in. Yay! So if this interests you, then I encourage people to start checking smart contracts out and start building things. Or if you can't, then join a team, contribute to existing projects that are building things. There's a lot of kind of cool things happening in the Ethereum ecosystem these days. Thank you.